Hello, students. Science begins from our home. Our everyday life is full of scientific phenomena. If you observe your everyday life very closely, you can understand most of the scientific principle in a proper way. Our life and our surrounding is full of mysteries, and those mysteries can be solved with science. You know, we all are surrounded by many things, many matter around us. But are they of same? I'll give you a fine example that's on your screen. On your screen, you can see a beaker containing water and a glass full of lemonade. Are both of them same? Obviously, no. Water is made up of water molecule. Whereas if you look at lemonade, lemonade is made up of water, sugar, salt, lemon juice. So both of them are different because water is made up of only one kind of particles, whereas your lemonade is made up of several type of components. That means lemonade is a combination of different substances, whereas water is combination of only one type of substance. Another thing that is on your screen, which we use in our everyday life. One is your a pan made up of iron and a pan made up of steel. Dear students, what is the basic difference between them? Both of them serve the same purpose, but one is made up of only iron, whereas if you know, steel is made up of iron, carbon, chromium and nickel. That means steel is a combination of several different components. Iron purely made up of only iron atoms, whereas steel is made up of several different components. So dear students, what do you conclude from both of this example? We conclude there are certain substances in our surrounding which are made up of only similar kind of particles, whereas some other substances are made up of different kind of particles. So how can we classify them? What name do you give to them? One is called as your pure substances and another one is called as a mixture. Another example that I want to give you, that's on your screen. Every day we are using this one, a packaged milk. If you can read out, it is written pure, healthy. If you focus on the word pure, do you think the milk that we obtain is pure? Everybody out there will say, yes, sir, milk is pure because we are consuming it. But in a common man's perspective, if you see, milk is a pure substance. But think scientifically, is milk pure? Because just now I gave you the example of pure substances. Pure substances are those which are made up of same kind of particles. Whereas your milk is not made up of same kind of particle. Milk is made up of fat, milk is made up of protein. That means if you look at a common man's view, milk is a pure substance. But if you just change your perspective, milk is not a pure substance, rather milk is a mixture. So now onward you can say that milk is not pure, milk is a mixture. So today's our topic of discussion, as you all can guess, is classifying the substances around us and analyzing whether all the substances that we see around us is pure or not. So the topic is matter around us pure? That is the second chapter of your science book, is matter around us pure. So today's our topic of discussion will be based on classifying substances into different category, and our prime focus will be on discussing about mixture. So dear students, let us go on to the next part. After studying this chapter, what we are going to learn? How is it going to help us? At the end of this chapter, end of this module, we'll able to know about mixture, we'll about to know about solution, we'll about to know about concentration of solution, we'll able to understand the properties of solution, and we'll able to calculate the concentration of solution, what quantity is present in a given solution. So moving on to the next part. Now let us classify matter. As in your previous chapter, in the first chapter, you have studied that matter can be classified on the basis of their physical properties, that is solid, liquid and gases. But again, on the basis of chemical composition, matter can be classified as pure substances and mixture on the basis of chemical composition. So if you see the flow diagram on your screen, your matter first classified into two types, pure substances and mixture. Again, your pure substances is classified into elements and compound that we'll study at the end of this chapter. Next one is your mixture. Mixture is classified into two types, homogeneous mixture, heterogeneous mixture. So dear students, let's learn about what is homogeneous mixture and what is heterogeneous mixture. As you can see on your slide, on your screen, pure substances, you have a proper arrangement. Look at the mixture. Elements here, if you see, elements are made up of same kind of particle. Compounds where particles or atoms are combined in a definite ratio. Whereas mixture, if you see, that's a random manner, a random quantity. So we can see the definition of pure substance on the screen. A substance that consists of only a single type of constituent is called a pure substance. Example, we have already taken few more examples: iron, copper, water, carbon dioxide, sugar. These all are example of your pure substances. Coming to the next, mixture is a substance that consists of more than one kind of pure form of matter. When we mix several different type of pure substances together, we call it as a mixture. So we'll learn, as you know, science we can learn by doing only. So I'm going to show you some of the activity which is given in your book to understand what is a pure substance and what is a mixture. So let us do some activity and let's try to find out what is the difference between a pure substance and a mixture. So dear students, let's see and perform certain activity to understand the basic difference between pure substances and mixture. As you can see, I am holding a beaker containing water, and you cannot see any other visible things here, completely transparent, and that means it is only made up of water molecule. So it is a pure substance. But if I mix something to it, if I mix certain things to it, if you can see, I am holding copper sulfate, and as you know, copper sulfate color is blue in color. So I am adding some copper sulfate solution to it. Let us stir it. If you stir it properly, that means I am adding another substance to it. Now the property has changed. The substance right now I am holding is not a pure substance because I have added a certain things into it. This substance is not made up of one kind of particle. Rather, it contains water molecule and it also contains copper sulfate. That means it is a mixture. So the basic difference between pure substance and mixture is that pure substances are made up of one kind of particle and your mixtures are made up of several kind of particles. That means I can say when we combine more than two pure substances together, that will become a mixture. And another very important thing that we need to note here, whenever we are preparing a mixture, that mixture should be, that component should be non-reacting in nature. Why is it so? Because if your component will start reacting with among each other, then they will not give us a mixture, rather they will give us a compound. So a mixture, the components are always non-reacting in nature. They do not react with each other. That means if I want, by certain process, I can separate the components. That means in a copper sulfate solution, I can separate the water molecule and also I can separate the copper crystals. That is, a copper sulfate crystals I can separate out by the process of crystallization. But if they are reacting in nature, they will form a new product which by any physical method we cannot get it back. So for a mixture, to prepare a mixture, we need to have two or more non-reacting substances. Now students, one thing that comes into our mind, the mixture that we see around us, are they of same type? All those mixtures that we see around us, are they of same type? Let us understand that also with an activity. So let us move on and perform certain activity to understand whether mixtures are of same type or there is also several types of mixture. As you saw that it is a mixture of copper sulfate and water. I'll show you another experiment where we'll add sodium chloride. I have taken sodium chloride, a test tube containing water. I'll add sodium chloride into it and will shake it properly so that it will mix. Student, observe it carefully. If you see, this solution or this mixture is transparent in nature, whereas this one is your blue in nature. That means both are mixture but are having different color. That means they are different. If you go to some other experiment also, I have lemon in my hand. You must be feeling very thirsty. If you are feeling thirsty, I can prepare you a lemonade for you, or I can give you a process to prepare lemonade. In a beaker I am having water. On my right I have a lemon. So what I'll do, I'll squeeze the juice into it and let us see what happens. So squeezing the juice into it and stirring it properly will give us a mixture of lemon and water, which we call as lemonade, mixture of lemon and water. So what do we observe here? There are different type of mixtures are possible. Dear students, let us try to classify them. On your screen, that is, there are two types. One is of homogeneous mixture and another one is heterogeneous mixture. Which are the mixtures that we call it as homogeneous mixture and which are the mixtures that we call as heterogeneous mixture? Homogeneous mixtures are those mixtures where the components are thoroughly mixed, where we see the components are uniformly distributed. For example, in case of your lemonade, the lemon juice and water, they are mixed thoroughly with each other. That means you cannot distinguish between which one is your lemon molecule and which one is your water molecule. There is no clear distinction between them. As there is no clear distinction between them, and if you taste that entire mixture, or every part will have the same taste, a slightly sour in taste because I have added lemon. So this gives us an idea that a homogeneous mixture are those mixture in which the components are uniformly distributed. The particles are not visible to our naked eyes. That means we cannot distinguish between water molecule and we cannot distinguish between the lemon juice molecule. That means it's a homogeneous mixture. Coming to the heterogeneous mixture, the definition on your screen, a mixture that does not have uniform composition, that is, has a visible boundary of separation between its constituent, is called as heterogeneous mixture. That means we'll prepare a mixture in which the components will be clearly visible to us. That means that both the component we can distinguish between them. For example, I have calcium powder with me. So calcium powder, that is calcium oxide, I am having calcium oxide, and I'll take another test tube containing water and to it I will add calcium oxide. What you will observe? If you observe it very carefully, by mixing it, I have shaken it thoroughly, but after some time, what you will observe, at the bottom of the test tube, gradually the particles are settling down. What does that mean? That means the calcium oxide powder is not getting uniformly distributed throughout the mixture. If you can see, at the bottom of the test tube, the calcium oxide powder is settling down. That means we can see a clear visible boundary of separation between them. So that we'll call as heterogeneous mixture. We can understand it with much more clarity if I prepare another one. That is, I'll take in one beaker water, I'll take. In another beaker, we'll add some amount of oil into it. If you observe it, if I add oil to it, observe it very carefully, dear students. We'll add water, we'll add oil, let us stir it properly, thoroughly. Will what do you expect? Are they going to mix with each other? The answer is no. As you know, oil and water does not mix with each other. You can clearly see a distinct layer between water and oil. Oil is floating on water and the water is at the bottom. There is two different layers. The upper part, if you can see, that is your oil, and the bottom part, if you can see, that is your water. That means there is a clear boundary of separation. So this is an example of your heterogeneous mixture. So dear students, what do we have learnt here? That in a mixture, if the constituent particles can be seen through our naked eyes, we can distinguish between them through our naked eyes without taking help of any kind of instrument. Those type of mixtures are called as heterogeneous mixture. And you see, in case of heterogeneous mixture, there is no proper or uniform composition. There is no uniform distribution between the component, and we call it as heterogeneous mixture. Dear students, from the activity, now I think it is very much clear to all of you that a mixture can be classified into two types. One is homogeneous mixture and another one is heterogeneous mixture. If you see the distribution of the particle or the component, here is a flow diagram on your screen. If you see the red dot and the green dots, in case of heterogeneous mixture, if you see, one part is your the red dots and one part is your the green dots. That means they are not uniformly distributed. But if you see the homogeneous mixture, the red and green dots are equally distributed in each layer. So that is what we say as your uniform distribution in case of homogeneous mixture and non-uniform distribution in case of heterogeneous mixture. Dear students, we'll take one particular example today about homogeneous mixture, which we call as your true solution. There are several type of mixture that we see in our day-to-day life, which are true solution or are homogeneous mixture. For example, we discussed about mixing sodium chloride in water. That is a homogeneous mixture because the sodium chloride crystals get thoroughly dissolved in water and uniformly distributed throughout. Another example that we saw right now, that is adding lemon juice into water. There also what we saw, there the lemon juice and water is getting thoroughly mixed with each other, and because of that we call it as a homogeneous mixture. So if you characterize the properties of a true solution, we call it as solution is a homogeneous mixture. In case of, as we are discussing several times, particles, that means there must be a size of the particle. So in case of pure homogeneous mixture, in case of true solution, the particle size is always less than 1 nanometer. 1 nanometer is equal to 10 to the power minus 9 meter. The diameter, if you see, the particles we assume as spherical in nature. If you try to understand, if you take a sphere and the diameter of that sphere will be 10 to the power minus 9 meter. It's so small that it is not visible to our naked eyes. And that is why we cannot distinguish between the components of a true solution. Because of the small size of the particle of a true solution, we cannot distinguish between the components because of their small size. Now, another property if you see in case of true solution, if you allow a light to pass through it, then the light will not get scattered by that particle. This scattering of light, one of the phenomenon which is associated with it is called as your Tyndall effect, where if you allow a light to pass through a particular mixture, if the path of the light becomes visible through that mixture, that means if I take a solution, allow a light to pass through it, and if the path of the light through the solution becomes visible, then I will call it as Tyndall effect because the path of the light becomes visible. But under what circumstances, under what situation light will get scattered? If the particle size are big enough. That means if the particle size are greater than 1 nanometer, then only they will able to scatter a beam of light. But in case of true solution, as the particle size is less than 1 nanometer, they cannot scatter a beam of light. Hence, they do not show Tyndall effect. Another very interesting fact about your true solution is that the particles or the components will never settle down of their own. That means if you leave them undisturbed for several hours even, the components of a true solution will not settle down of their own. That is why we call it as they're highly stable in nature. The components of a true solution is highly stable in nature because they do not settle down. Another very interesting fact about it, that if you take a true solution, you cannot separate the component with the help of a filter paper. That we can also verify with the help of an activity. If you take a true solution, a homogeneous mixture, and take a filter paper, you will observe by passing that mixture through filter paper, none of the component will get separated out. Nothing will get deposited on the filter paper, indicating that the particle size of your true solution are so small that they can pass through even ordinary filter paper. That means a true solution cannot be separated using a filter paper. So these are the certain properties. If you summarize it, true solution is homogeneous in nature. The particle size of true solution is less than 1 nanometer. That means they cannot be seen with naked eyes. Due to the small size of particle, they do not scatter a beam of light, hence do not show Tyndall effect. A solution is highly stable, that the particle never settle down even if they are left undisturbed for several hours. Particles of a true solution cannot be separated using a filter paper. Now let us understand the different components which are present in a true solution. Generally in class 9, we discuss about binary solution. Dear students, binary solution means a solution containing only two components. So here, when we have only two components, we give a special name to them. In case of a true solution, we have one solute, another one we have a solvent. Solute and solvent gives us solution. Now the question comes into mind, which component will be known as the solute and which component will be known as the solvent? So dear students, in a particular mixture, specifically in case of true solution, the component which is present in a larger amount, that will be your solvent, and the component which one is present in lesser quantity, then that one is known as your solute. So when we go to higher class, there you will study that solute is that component whose number of moles is less. If the number of moles of a particular component is less in a true solution, that will be a solute, and if the number of moles of a particular component is more, then that will be called as solvent. But in general way, we say the substance or the component which is present in larger quantity, that one is your solvent, and the substance which is present in lesser quantity, that is called as your solute. For example, if you prepare a true solution of sodium chloride in water, we call sodium chloride is your solute and water is your solvent. If we prepare a solution of lemon juice in water, we call lemon juice as your solute and water as your solvent. Similarly, a very familiar example that we are all surrounded by, that is the air present in our atmosphere. Our air is also an example of homogeneous mixture, where the gases which are present in larger quantity, that will be your solvent, and the gases which are present in lesser quantity, that will be your solute. For example, in atmosphere, nitrogen is present in a larger quantity. That means nitrogen is the solvent. oxygen is present in a lesser quantity. That means your oxygen is your solute. So solute and solvent, when they mix together, we prepare a solution. Now students, based on the physical state of the solute and solvent, we can have several type of solution. We can have solid type of homogeneous mixture. We can have solid liquid type of homogeneous mixture. We can have liquid type of homogeneous mixture. We can have gas in liquid. We can have gas in gas. So there can be several types of homogeneous mixture. There can be several type of true solution based on the physical state of the component or based on the physical state of your solute and solvent. So dear students, let us summarize what we have learned today. We started classifying substances. One is your pure substance, another one is mixture. Your pure substance are classified into two types. One is element, another one is compound. Your mixtures are classified into two types. One is homogeneous mixture, another one is heterogeneous mixture. So under homogeneous mixture, we have true solution and we studied the properties of true solution. Now, let us try to know how far we have learned, how far we have understood all these concepts. So, few questions are for you. First question, what is the basic difference between homogeneous mixture and heterogeneous mixture? The answer to it is, homogeneous mixture, the components are uniformly distributed throughout, whereas in heterogeneous mixture, the components are non-uniformly distributed. Second question for you, milk is a homogeneous mixture or heterogeneous mixture? The answer is, although it looks like homogeneous, but milk is a heterogeneous mixture. Third question to you, will you able to separate a homogeneous mixture with the help of a filter paper? The answer is no, because the particle size in case of your homogeneous mixture is very small. That will pass through the filter paper and we cannot separate a component of homogeneous mixture with the help of a filter paper. So that's all for today. The next class will continue with the rest of the concept. Revise the chapter thoroughly, go through all the concepts properly and take care of yourself. Thank you all.